Oh,
Our project covers respirable dust sampling at a composites manufacturing site. This site primarily manufactures engineered composite parts for use in the aerospace industry. Engineered composites are created by impregnating woven fibers with a binding material. It is lightweight and stronger than its individual parts, and it's widely used in aerospace where the strength to weight ratio is critical. Cutting, grinding, and drilling of composite parts can create significant respirable dust exposures and lead to serious health outcomes. In our study, we sampled respirable dust at a manufacturing site and compared our measured levels to regulatory and voluntary exposure limits.
The method used to sample for respirable dust was the NIOSH method 600, which falls under particulates not otherwise regulated. For pre-sampling, we had two cyclones, 3-piece cassettes that contained 37 millimeter PVC filters that were pre-weighed, and the pumps were also pre-calibrated before sampling. After sampling, the filters were post-weighed and the pumps were post-calibrated. Using gravimetric analysis, we subtracted the pre-weight from the post-weight and were able to calculate a concentration from the volume of air and the amount of dust on the filters. From that, we were able to calculate an 8-hour TWA and compare it to the OSHA and ACGIH PELs.
We were able to put cyclones on each of 2 workers. The first worker primarily drilled holes and grinded edges onto the molds, while the second worker was primarily cutting strategic holes into the molds. Each of the workers were wearing PPE. We decided to switch the cassettes halfway through because of high amounts of dust in the grinding booths. Those cassettes are represented by the letters A through D. Worker 1 was measured to have an 8-hour time-weighted average of 4.24 milligrams per meter cubed, while worker 2 had an 8-hour TWA of 5.46 milligrams per meters cubed.
using these results, we compared their results to the respirable dust exposure limits set by OSHA and ACGIH. Worker 1 was found to be under the OSHA PEL of 5.0 milligrams per meter cubed, while worker 2 exceeded the OSHA PEL, and both workers exceeded the ACGIH TLV of 3.0 milligrams per meter cubed. Since these exposure limits were exceeded, we recommend the following controls.
Looking into potential engineering controls, a ventilation system exists inside the booth, but it is not optimally placed to remove dust from where the grinding is occurring. So we would first recommend that ventilation system be moved and optimized to remove dust as it's created. Additionally, the ventilation system could be improved with additional vents or a more powerful vent. And finally, a wetting system could be put into place that will spray water jets where the material is being cut, and these water jets will prevent dust from ever being introduced into the air where it can be breathed. Looking into administrative controls, which are generally less expensive but might not be quite as effective, we could recommend that workers be put on shifts where they do other jobs that are not exposed to dust for part of the day, and then they come into the grinding booth the rest of the day to reduce the amount of exposure they receive. And additionally, more workers could be hired to reduce the shift lengths that each worker spends inside the grinding booth. And finally, looking at PE controls, one worker was using a powered respirator system known as a PAPR to reduce the amount of dust that they were exposed to, while the other was only wearing a passive mask, which is not as effective. So we would recommend that all workers be required to wear a PAPR and are trained on how to properly use and maintain the PAPR. Although this is not sufficient, considering that they're exposed to limits above the PEL, and so additional administrative or engineering controls would also have to be implemented.